Hello, this is Ujjwal Saxena again, and continuing to the with LTSPICE. Today we are going to learn about the power calculation in LTSPICE. This is the most interesting feature which LTSPICE provides because in multisim you can't calculate the power. Uh, so let's make a simple circuit. Uh, First of all, let's choose an op-amp. Okay, op-amp is here. Op-amp. Double click this. uh, all of these are op-amps, different op-amps, but most of them don't have their spice models defined in the LT spice. That's why this software has such a low size, such a small size. This universal op-amp 2 has its spice model defined in the software, so I have chosen this. Let's make a Schmidt trigger. So for that I need two resistances, one here and one here. Escape this, and I'll be needing, go back, three voltage sources, one for the input and two as VCC and VEE. Okay, so that's all. Apart from this I'll be needing ground. Okay, so ground and a ground here. Escape. Now let's make the connections. First of all, connect this to the input, then I'll provide this with the plus VCC, and now a negative voltage. So I'm providing them with a common ground. You can use different individual grounds for both of these voltage sources. I'm connecting a resistance between the output terminal and the non-inverting terminal, and a resistance between the non-inverting terminal and the ground. Okay, yeah, this is done. So moving to the next level, we have to assign them with the values. So right click on this, give it 1K. You can choose different values too, just using any random values. Right click on this, 9 volts DC. Click on this, 9 volts DC. Okay, okay, I forgot to give this resistance, this voltage source a ground, so I'm giving it a ground. Okay, now this has to be advanced voltage source, which should be sinusoidal. So 0, 5 volts, frequency let's say a kilohertz, and 40, 30, any number of cycles. Now this is done. So what else do we need is to run this. We have to mention the transient commands. So stop time, let's say 0.003 seconds. Time to start 0, and 0.003 seconds. 0 and make this 9. Okay, now you can see the output. Okay, I guess that it is elongated very much, so I'll just lessen these values a little. Okay, I'll run this again. Okay, so you can see that the input is a sinusoidal wave, and for the output just click on this and you'll see that it has been converted to pulse. Now you can see, as you'll move your cursor at this top, at the bottom you'll see, at the left bottom corner, you'll see the x and y coordinates have been defined. The y coordinate says 8.98 volts, which means it's approximately 9 volts, and bottom one says minus 8.98 volts, that's approximately 9 volts. So it is plus to minus 9 volts from top to bottom. And one thing more, you can calculate the time taken for a transition by seeing the x coordinate. Like this coordinate says 0.672 milliseconds, and as you'll move up, it's saying 0.679 milliseconds. So it has taken 0.007 milliseconds to make this transition. Okay, so moving towards the power calculation thing, uh, as you'll move to any of the component, it shows different icons. Now click Alt and move again to the components. The icon that is appearing will change. There's a thermometer uh, appearing on these components. This shows the power consumption. If you'll double click this, you'll find the power consumption graph in the specific component. Now go to the label, click Control, and again double click. You'll find the average power that has been consumed is 308.36 microwatts. Similarly, you can calculate the power consumption in various components. Like if I want to see the power consumption of this voltage source, I'll go to it and I'll click on this. I'll again go to the label, Control, and click minus 19.348 milliwatts. That means it is giving the power. You can see that it's written over here. Uh, this is a graph between the voltage at the node 1 and the current through V2. That was what which was desired. The power consumption by this voltage source, and it has been plotted over here. Now another command in coding which you can use is the dot measure command. For that, you need to click on this schematic, go to dot op, and type dot measure space tran means transient. uh, Give this a variable name. Let's say I'm using this as PWR V1. That means power through V1 or power consumption by V1. Right? AVG bracket, and code this label inside this bracket. Okay. So that says V bracket, inside the bracket, N001, outside the bracket multiplication sign, then I, and bracket in which we have to write V2. Okay, this is done. Now you have to mention the time from 0 to 0.00003 seconds, or you can take it as 0.09 seconds. Say okay, paste this here, and if you run this again, no change will appear on this graph. Okay, do one thing, first of all, save this. Save as Ujjwal Saxena uh, 4. Save this on the desktop. Okay, desktop. Save. Now again run this. So what it has done, it has made a file on the desktop by the name Ujjwal Saxena 4, and here you can see a notepad file in which the output is always saved for LTSPICE. This says direct Newton iteration for .op point succeeded, which means we have succeeded in our iterations. Power 1 is this much. This much is the power from 0 to 0.009 seconds. Like this, you can calculate the power through any component. One thing more, this is Ujjwal Saxena ECE. Blog ID is erujjwalsaxena.wordpress.com and email ID is er.ujjwalsaxena@gmail.com. For more videos, you can refer to these IDs. Okay, coming back to the LTSPICE, you can see, you can calculate the power consumption through any of these components like this. And since LTSPICE is widely accepted in research purposes, uh, while multisim is not that much widely accepted, so and as we know that power consumption is the burning issue in electronics these days. We all are working to minimize the power consumptions. So these topics can be uh, a good research topic. So you can just calculate your power, the powers like this, and continue with your research purposes. I'll mention some of the more interesting features of this LTSPICE in my later videos. So this is all for now. Thank you. This is Ujjwal Saxena.